Hello, everyone. Welcome once again to this session. I'm your trainer and the host for today, Joshua Obuya. Today, we're going to look at determining prime numbers. So, prime numbers are numbers which may be quite familiar to us. And I suppose we all know that they are numbers that are divisible by only one and the number themselves. That means they have only two factors, and that's what makes them prime. So, in this session, we're going to look at basically just how to find prime numbers. How do you determine if a number is prime or not? And at the same time, also, we'll try and discuss various aspects about prime numbers that you may need to be aware of that can be quite applicable and also helpful in an exam settings. That's what we're looking at. So just to start us off, we'll just dive right in. So what is it about these prime numbers that we should know? What are the basics? The basics are that they are number properties concepts because they fall under that topic. That's where you'll find them. And they rely heavily on multiple number properties aspects because they are numbers to start with, and therefore they will inherit almost all the other properties that you do have of numbers. And therefore, you should know about them. Things like the addition properties, multiplication properties. So if you multiply a number by, let's say, an odd times an odd gives you an odd, and odd plus an odd gives you an even. Prime numbers except two is actually even. So the rest of them are odd. So every other prime number being odd. So if you're trying to answer questions, you should have these at the back of your mind and don't forget them. Keep them in place. So they'll rely on aspects like divisibility tests. Yeah, they'll also rely on aspects like the last digit of a number, in that when you have the last digit of a number being this one, then what will it be a prime number or not, or how will it affect, or something around the sorts. It will also rely on squares and square roots, simply because that's also an aspect which you look at. This aspect is not so common, but we will look at it to just see how this one comes to play. So squares and square roots. And lastly, before we dive into the details, just know that the general form of prime numbers. So that means they are basically, the general form is 6n minus 1 or 6n plus 1. So what that means is that if you add 1 to a prime number or subtract 1 to a prime number, it will be a multiple of 6. Let's take, for instance, let's say the prime numbers you may know of, let's say 7, 11, 13, 13, and then 17, 19. Each of them, try subtracting or adding 1 to them. You'll see that it is a multiple of 6. This is one also way of trying to see if a number could possibly be a prime number. So apart from 2, everything else is odds. If you give a number, let's say, of 687, something like that, then will this be prime? One way of looking at it is, let's say, if you try and add 1 to it, will it be prime? So since it's an odd number, most likely, if you add 1, it will be now even, or subtract 1 will be even. So let's see. So 6, and then let's say 6 is a multiple of 6. So 8 in itself is a multiple of, is actually, if you divide it by 6, you'll have 2. 26, 28, it's not. So most likely this may not be a prime number. That's just off the head that you may look at it. But you may need to carry out some more tests to determine if this prime number. And the test you will do will actually rely basically on let's say the divisibility tests. That's what you'll do use heavily. So we'll look at how you can combine these to make that. So let's proceed. So let's just take a number and just see all these come to play, all of it. For example, let's say we have a number like 677. Is this number prime? So yes or no? That's a question of B. So how will you go about that? One of the for you to determine if it's a prime number, you need to show that it's only divisible by one and the number itself, x, let's say x. So for you to do this, you need to actually do the divisibility tests of all the numbers that you may be able to find, divisibilities of all the numbers. But that will take you so much time. Tests, right? Of numbers. So let's say 1 till, let's say, if you do the of basically prime numbers, if you can be able to do that, then yes, that will be it. But how much time will it take you for 677? Yeah, this assuming that you know the prime numbers below 100, because you should know them offhand. It will save you some time. You should be able to at least recall what the numbers are below the numbers below 100. So anything above 100, then now you can probably try and calculate and see if it's divisible, if actually it's prime or not. So You'll need to do the divisibility tests of all the numbers that would be below it. So that will be 8. But a clever trick will be to do divisibility tests up to the root of, let's say, x, and then you add 1 to it. So the root of x to it. This is a clever trick used in programming that actually can be used to find the actually to test if a number is prime. Because if you can find the lowest, actually, let's say a number, if actually you can find the square root, let's say 37. If at all, let's say you do divisibility tests up to you see the square root of 37 minus 1, something, yep, or 37, then I add 1 to that figure, then this will be close to, let's say, 6, and then plus 1 will be equal to 7. So if you can try numbers between 1 and 7, or prime numbers between 1 and 7, and you find that they are not divisible by this, then that number is actually a prime number. You don't need to go beyond this. For instance, you just go between, let's say, 37, you actually just try 2, it's not 3. Yeah, the visibility test of that 7 be 3 plus, okay, for 3 is 3 plus 7 is 10. That's not a multiple of 3. So neither is it of 9. So that's not there. For 5, ends in 5 or 2, 5 or 0. It's not there. Case with 7. So you're done. So you don't need to go to 11, 12, 13, and so on and so forth. That's not it. So that's actually how powerful this step can be.
You're watching Success with Bob Mwiti Show, presented to you by Upstack America. Upstack America is a consulting company that helps immigrants find amazing higher education and job opportunities in the tech industry in the United States. You can find our programs by going to www.upstackamerica.com. Upstack America, we wake you up to the unlimited potential.
So you just need to find the divisibility test of the numbers up to the square root of the number, then you just add 1 to it. That's basically it. So if you're given a number like, let's say, a big number like, let's say, 677, then that's what you will do. So the next thing is probably trying to find the square root of a number quickly, because time is of essence in the GMAT exam. You don't have all the time. The time you have is really precious. I need to use it in the most shortest time possible. So let's say, let's try and find the square root of 7. So find the square root, 677 rather, right? So how would you go about this? One of the quick ways to finding any square root of a number is, the first thing is check the last 2 digits, that number, and then look for the squares of numbers between 0 and 9. The last digit, if the last digit corresponds to the square roots of a number, then most likely it could be that. For instance, let's say for 677, you try and see here, we're saying there is no number which corresponds to it. And what will be it? Let's try and pick a number close to 677, just so that you can find a square root close to 677. So let's say 670 what? Let's try a number, say 676. Yeah, we're just improvising. So square root of 676. So the last 2 digits here will actually have a 6 there. So end up with a 6. So it could be a 4. Could be a 4, right? Could actually so the unit digits there will end with a 4. That's the unit digit for the square root. How about this other part? For 6, we'll try and see if at all the number is probably, you have 2 numbers, you have a 4 and a 6, sorry. So they have a 6. So it could have actually, the unit number could be a 4 or it could be a 6, because you have two numbers here whose unit digits are 6. So you don't know which one it could be. So once you have the first 2, the unit digits will be a 4. Then how about this remaining one? For the remaining one, we try and find its square root of this number for which it won't exceed that digit. So if it's 6, we find the square root of the integer, of this integer in an integer form that won't exceed 6. So in this case, we have only 2, because 2 squared is 4. If you go 3 squared, it's going to be 9. So it's going to be a 2 with this number. So it could be 24 or 26. So the question is, if it's actually 24, 26, how will we know which one is which? Now, to determine which one it will be, we need to distinguish between the two. So for this one thing which will stick out is, many times it's going to be on either sides of 5. It's going to be either 25 or 26, or it's going to be 24, 26, or number be either 14 or 19. But you're going to have 5 as a number in between them. And finding the square root of a number actually ending in 5 is quite easier. Like, let's say the square root of, let's say, or the square of a number which has 5. Square of 25, as you would know, is 625. So if actually, let's say it's 15, be to 25. But how would you find this? If you don't know if it's a big number, let's say 75, and you don't know how to go about this, you would probably just, how you do this is, the common thing is that to end up with a 25, that's given for all squares of numbers with 5. And then, so 25 is for the square of the unit digits. Then for these tens digits, what you'll do, you'll take actually this value times, so x into x plus 1. That would be the tens value. So this x being this value. So 7 times 8, 56. So be 56, 25 will be the value. So that will be it. So that is now will be how you get that. So in this case, since we're looking at only 25 as the number, and 25 squared is 625, the question comes, is 676 less than or greater than 25? This one is greater than 25. That means it will fall on the number above it. So 26 will be the square root of, actually will be the square root of 676. Therefore, the square root of 677 will be approximately very close to 26. In fact, it will be just 26 point something. So what this means is that now we'll find the square roots of the numbers. We just try dividing 677. So divide 677 by numbers x less than 26. 26 plus 1, let's say 27, but 26 you just do it. All right. So you don't need to go 28, 29, and so on and so forth. But for 27 in itself, that means we can break this down to what? This can be broken down to factors of actually 9 and 3. So if you have 9 and 3, if it's a multiple of 9, then yes, it's going to multiple 27. So we don't need to get to the 7. If it's a multiple of 13 as well, then actually also it's a multiple of and 2, then it's a multiple of 26. Are you seeing that? So we don't need to get 26 in itself. So if it's a multiple of 12 and 2, so we don't really need to get all the way to the 20s, as you can see. So many times we'll just try with the prime numbers less than that value. So the prime numbers will be probably up to 23. That's what we look at, because if you can find the divisibility test of other numbers, then that is it. So we're only dealing with prime numbers less than 27 in this case. That will help us get to know if a number is prime or not. Simply because any other number beyond that would be multiple of other prime numbers, and therefore that will be taken care of. You won't need to spend all that energy. Remember, time is of essence in the GMAT exam. So this is something I need to work with. So let me try. So we'll modify this to divide by prime numbers. Oh, my bad. Sorry about that. It's so we're going to divide this by prime numbers, right? Prime numbers of x less than 27. So what numbers are we looking at? We're looking at 2, 3, 5, 7, 11, 13, and what else? 13 and 17, 19, and 23 now. So this is what we're looking at. But do we have to go through all these numbers to try and get to see that? Of course, we can rule out, we can try for the first below 10 because, okay, let's say up to 11, we can try and do the divisibility test because it should be pretty much off our heads. So for 2, it needs to be even, that's not. For 3, it needs to be, if you add the numbers and the sum of all the value of all the digits in that number is a multiple of 3, or then it's divisible by 3. In this case, 7 plus 7 is 14, plus 6 is 20. That's not a multiple, but it's not. Neither is it of 5. For 7, how do you go about? For 7, the divisibility test is you check the number, the unit digit, 7, then subtract from the rest of the digits. So that means 67 minus 7 is equal to 60. If it's a multiple of 7, then it's divisible. That's not. So it's not divisible by 7. So far we're out. So let's say now 11. 11, you take the alternative numbers and then you sum them and subtract them. Find the difference. It's a multiple of 11, then it's divisible. So 6 plus 7 is 13. So 13 minus 7. That will be what? 6. 6 isn't a multiple, so not divisible by that. So we've just ruled out all these numbers outside less than 13. So the next thing is not starting from 13. And because it's not divisible by either of these, it will have to be either a product of the remaining numbers, right? So are you seeing how these number properties tend to combine? Because we're seeing products of these. One is a factor of the other, and if one is a factor, then that means the other one is. So the remaining numbers, we need to see if we can multiply either of these numbers, and the last digit is going to be the unit's value. Yeah, I hope I'm making sense. So let's say we multiply these numbers, and if you multiply them by themselves, across themselves, we will end up having the unit digits being 7. That's the only thing you need to check. You don't need to multiply all of them. So let's try. 3 times 7 is 21 out. 3 times 9 is 27. Yes, so we could have 13 times 19. That's a possibility. And then we have each of them. 3 times 3 is 9, so that's out. Then let's try again. 7 times 9 is 50, 63, that's out. 7 times 3 is 21, that's out. So that's out. 9 times 3 is 27, so that's the same thing which you had. So you only try these two, and let's see if it gets close. So you get 7 carry 2, 1 times 9 is 9, then plus 2 is 11, then you add 13. So 7, that is 4. 47, that's not it. So of all the prime numbers we've tried below 27, none of them actually has proved to be a multiple of this, and therefore 677 is prime. Sorry about that. Therefore 677 is prime. So it's kind of a long shot, it's kind of a combination of things, but you can see how putting all those concepts together can really help you finding that. So I hope this is some new information. I hope that you find it valuable. So if you found this valuable, please feel free to share with your friends and also comment. And come once again next time. We'll have some more. Thank you. Bye.